Welcome back. Am I the only one that didn't know how crucial TCP/IP is to our digital lives? Imagine a world without the internet. No instant messaging, video calls, or online gaming. This reality, almost unfathomable today, would be our world without TCP/IP. From loading websites to sending emails, TCP/IP is the invisible force that binds our digital lives. This intricate protocol suite acts as a common language, enabling devices across the globe to communicate seamlessly. Understanding TCP/IP, however, can seem daunting at first glance. By understanding the roles of each layer and how they interact, we can gain a newfound appreciation for this essential technology. Whether you are a tech enthusiast or a curious beginner, join us as we unravel the secrets of the TCP/IP model. So, buckle up and prepare to explore the fascinating world of TCP/IP, the silent orchestrator of our connected world. The origins of TCP/IP can be traced back to the early days of the Internet. In the 1970s, the U.S. Department of Defense funded research to create a robust and fault-tolerant communication system, ultimately giving birth to TCP/IP. TCP/IP breaks down communication into layers, each with a specific function, much like how a postal system works. At its core, TCP/IP is all about breaking down data into manageable packets and efficiently routing them to their destination. Imagine sending a letter. Instead of sending the entire letter as one piece, TCP/IP divides it into multiple envelopes, each with the recipient's address and a specific order. These envelopes are then sent independently across the network and reassembled at the destination, forming the original message. Each layer in the TCP/IP model has a role, from handling the physical transmission of data to ensuring it reaches the correct application. This resilience and adaptability made TCP/IP the ideal choice for the burgeoning internet. Today, TCP/IP remains the bedrock of the internet, connecting billions of devices worldwide. To understand the intricacies of TCP/IP, we must delve into its layered architecture. The TCP/IP model comprises 4 distinct layers, each responsible for a specific aspect of data communication. This modular approach simplifies network design and troubleshooting. Think of it like building a house. You wouldn't construct walls on top of the foundation without first laying down the framing and flooring. Similarly, each layer in the TCP/IP model builds upon the one below it, creating a robust and efficient system for data transmission. At the bottom of the stack lies the link layer, responsible for handling the physical transmission of data across the network medium. Next comes the internet layer, responsible for addressing and routing packets across different networks. Above the internet layer resides the transport layer, which provides a reliable connection between applications running on different devices. At the bedrock of the TCP/IP model lies the link layer, often referred to as the physical layer. This layer is responsible for transmitting raw data bits across the physical network medium. Think of it as the foundation of a house, providing the essential groundwork upon which all other layers are built. The link layer deals with the physical characteristics of the network, such as the type of cable used, signaling methods, and data transmission speeds. These signals travel through various mediums, including copper wires, fiber optic cables, and even wireless radio waves. Network interface cards, NICs, operate at this layer, providing the physical interface between a device and the network medium. Without this fundamental layer, none of the higher-level functions of the TCP/IP model would be possible. Building upon the physical foundation laid by the link layer, the data link layer introduces mechanisms for organizing data into frames and managing access to the network medium. This layer acts as a network within a network, ensuring reliable data transfer between devices on the same local network segment. Imagine a busy intersection with cars coming from different directions. The data link layer acts like a traffic signal, controlling the flow of data frames to prevent collisions and ensure smooth transmission. It establishes logical connections between devices on the same network segment, providing error detection and correction mechanisms to guarantee data integrity. By providing reliable data transfer within a local network segment, the data link layer prepares data for its journey across the wider internet. As data ventures beyond the confines of a local network, it enters the realm of the network layer. This layer is responsible for addressing and routing data packets across multiple networks, ensuring they reach their intended destination anywhere in the world. Think of the network layer as a postal service. Just as postal codes and addresses guide letters to their recipients, the network layer utilizes IP addresses and routing protocols to navigate packets across the vast expanse of the internet. At the heart of the network layer lies the Internet Protocol, IP, which defines the addressing scheme and packet structure used for data transmission. Routers, specialized networking devices operating at the network layer, act as traffic directors, forwarding packets towards their destinations. The network layer plays a crucial role in enabling communication between devices located on different networks. While the network layer focuses on delivering packets across networks, the transport layer provides a reliable connection between applications running on different devices. This layer acts as a liaison between the application layer and the underlying network, ensuring data is delivered accurately and in the correct order. Think of the transport layer as a dedicated courier service. Just as a courier ensures a package reaches the correct recipient within a building, the transport layer guarantees data is delivered to the appropriate application running on a device. Two primary protocols operate at the transport layer: TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. TCP is a connection-oriented protocol, meaning it establishes a dedicated connection between two devices before transmitting data. The transport layer plays a vital role in enabling seamless communication between applications. To illustrate how the layers of the TCP/IP model work together, let's follow the journey of an email from sender to recipient. First, at the application layer, the email client formats the email and prepares it for sending. It uses the SMTP, Simple Mail Transfer Protocol, to send the email to the sender's email server. Next, at the transport layer, SMTP, operating on top of TCP, divides the email into smaller segments and adds sequencing information to ensure they are reassembled in the correct order at the recipient's end. Moving on to the network layer, each segment is encapsulated into an IP packet, adding the source and destination IP addresses. Routers along the way use this information to forward the packets towards their destination. Then, at the data link layer, as the packets travel across various networks, this layer adds MAC addresses and error detection information to each frame. Finally, at the physical layer, the packets are converted into electrical or optical signals and transmitted over the physical medium. Upon reaching the recipient's email server, the process reverses, and the email is delivered to the recipient's inbox. This intricate dance between the layers of the TCP/IP model ensures that billions of emails are sent and received reliably every day. Thank you for watching. See you in the next video.